Sample problem 15.13. For each reaction, predict in what direction the equilibrium will shift when the volume of the reaction vessel is decreased. In this particular problem, these are issues of gases. Changing the volume does not have an effect on equilibrium for solids or liquids or aqueous, but it does for gases. So the gases are the key here. So let's begin with A. Phosphorus pentafluoride is in equilibrium with PCl3. So if they're already in equilibrium and then we make some changes, that will affect things. Now, the key to this is to count the number of moles of gases on both sides. If you're changing the volume, what that does is it changes the concentration of the gas. If the volume decreases, that means that the concentrations go up or the pressures go up, either one if you want to talk about it from that perspective. So let's write out the expression for K. Pressure of PCl3 times the pressure of Cl2 over the pressure of PCl5. Let me rewrite that. PCl5. Okay? Products over reactants. Now, we're going to decrease the volume. Remember what happens when you decrease the volume? If we have the volume here, and all the gases are mixed in here, and it's at equilibrium, and then we compress it so that the gases are in a smaller volume now, that changes their pressures. It increases their pressures. They will have higher pressures or higher concentrations if you want to look at it from that perspective. Okay? So that means they all go up. Okay? So essentially what happens then is the pressure of PCl3 goes up. I'll write it that way. Pressure of Cl2 goes up. They both go up. And the pressure of PCl5, it also goes up. All three go up. They're all gases, so all three pressures will go up. The question is, what has the larger effect, the numerator or the denominator? Here or here? Mathematically, if you increase one term, let's say you double it, and then you increase the second term and you double that one, and then you increase the third term and you double that one, you have a bigger change in the numerator than you do in the denominator. This is a bigger change. It's a bigger increase. The reason for that is that if you double something and then you double it again and then cut it in half, you doubled it. Right? If we're doubling this one and we're doubling this one and we're doubling this one, the doubling of this cancels with that one, and so overall we doubled it. So that means that Q has been doubled, which means it's larger than K. If Q is now larger than K, the reaction goes that way. So that means the reaction shifts left. Okay? So it's the fact that there's two gases here and only one there. Let's try another one. Remember, we're decreasing the volume. If we increase the volume, it would be the exact opposite. If decreasing the volume shifts it to the left, increasing it would shift it to the right. Okay. So let's try the second one. 2 PbS solid plus 3O2 gas in equilibrium with 2 PbO solid plus 2 SO2 gas. Okay? Now, let's write out the expression for K. Remember, we're only doing gases, so it'd be the pressure of SO2 squared divided by the pressure of O2 cubed. We're not going to include the solids in this expression because they are solids. They do not get included in equilibrium. So now, let's go to the next step. What we're going to do is we're going to decrease the volume. So that means that this one is going to go up and this one is going to go up. Both of them are going to go up. So now the question is, if you double something in the numerator and you double something in the denominator, what's the effect? Well, this one's squared and this one's cubed, right? So if I go for Q, if I double the pressure of SO2 and then square it, and then I double the pressure of O2 and I cube it, right? What happens compared to K? Let's just factor out the 2. You get 2 squared over 2 cubed, right? Times the pressure of SO2 squared over the pressure of O2 cubed. So what happens is this is just K right here. So what has happened to Q compared to K? 2 of these cancel with 2 of those, so you get a half, right? 1 over 2 is a half. So that means that Q sub P is 1/2 K sub P. That means it's smaller. If Q is less than K, that means the reaction goes this way. So it's going to shift to the right. Okay, now notice I'm saying doubling, and the reason I'm saying doubling is because mathematically that's the simplest mathematical change that you can make that, so that you can go through it. They're not saying we're doubling it, but we can use that as our example. Last one, part C. Part C says that you've got H2. These are all gases. We should be familiar with this one. We've done a few sample problems with this particular equation. Okay. Again, we're going to decrease the volume, which increases the pressure. So K is the pressure of HI squared over the pressure of H2 over the pressure of I2. Okay? Now, what are we going to do? We're going to double the pressure. So now let's do Q. Q, we're going to double the pressure. So we're going to have 2 PHI. Okay, pressure of HI. Let's do it this way. Let's take that parentheses out and move the 2 a little bit closer. We're doubling it, right? Squared. And then we're going to take 2 times the pressure of H2. I'll put that in parentheses. 2 times the pressure of I2. Again, I'm doubling it just for showing us what would happen. So now what happens? Let's factor out the 2's. 2 squared over 2 times 2. So it's 2 squared over 2 squared times the pressure of HI squared over the pressure of H2 over the pressure of I2, right? So this right here is Kp. 2 squared over 2 squared is 1. So in other words, Q equals K. What happens if Q equals K? That means you're at equilibrium, no change, no shift. No shift, Sherlock. It's not going to change, right? So there we go. So what happens is, if the number of moles of gas are equal on both sides, 1, 1, and 2, then essentially no effect. It's really the difference in moles of gas that make a change on this one. Okay? So this one's tricky, so make sure you try the practice problem A and B, and then also do any of the checkpoints at the end so that you can get even more practice on it.